Welcome to AI Frontiers, where we explore the cutting edge of artificial intelligence research. Today we're diving into 18 groundbreaking papers from the computer science machine learning domain, all published on a single remarkable day, October 15, 2025. This collection represents a fascinating snapshot of discoveries that could reshape how we think about artificial intelligence, from neural networks that learn like master craftsmen to AI systems predicting protein interactions with startling accuracy. Picture this. What if AI could learn like master craftsmen, adapting their techniques through experience and wisdom? On one extraordinary October day, researchers worldwide published 18 papers containing discoveries that could make AI systems 10 times more efficient, enable them to understand causality like humans do, and even help solve climate change. These aren't just incremental improvements, they're hidden gems quietly revolutionizing our technological future. From neural optimization breakthroughs to protein prediction advances, this treasure trove of research offers unprecedented insights into machine learning's explosive evolution. Today's journey takes us deep into tomorrow's intelligence, unpacking the future of AI research through this remarkable collection. These papers provide a unique window into the minds of researchers actively shaping artificial intelligence's future. We'll explore groundbreaking discoveries spanning from theoretical foundations to practical applications across diverse domains. Among these 18 papers lies one that could fundamentally revolutionize how we train neural networks, bridging control theory with machine learning in ways never before imagined. This episode offers insider access to the breakthrough ideas driving tomorrow's technological advances. Think of computer science machine learning as a vast digital ecosystem. A sprawling forest where algorithms grow like trees, each species uniquely adapted to solve different problems. In this ecosystem, some trees specialize in recognizing patterns in images, others excel at understanding human language, and still others master strategic decision-making. Computer science machine learning, known as CS.LG to researchers, represents the fertile soil nourishing this entire ecosystem. This field sits at the fascinating intersection of mathematics, computer science, and cognitive science, powering the recommendation systems curating our digital experiences, autonomous vehicles, navigating our streets, and medical diagnosis tools saving lives in hospitals worldwide. The first dominant theme emerging from these papers focuses on optimization and training methodologies. Think of training a neural network like teaching a master craftsman. You need not just the right techniques, but wisdom about when and how to apply them. The groundbreaking work on optimal control theoretic neural optimizer represents a sophisticated breakthrough bridging control theory with neural network training. Instead of relying solely on traditional backpropagation algorithms, this research demonstrates how dynamic programming principles can create more robust and efficient training procedures. It's like discovering that apprentice craftsmen have been using basic tools when sophisticated instruments were available all along, fundamentally shifting our approach to neural network optimization. The second major theme centers on architectural efficiency and model compression. As AI models grow larger and more powerful, researchers face challenges reminiscent of architects designing skyscrapers, maintaining structural integrity while reducing weight. The revolutionary paper on reversible model merging tackles this by developing methods to combine multiple specialized models into compact representations without significant performance loss. Meanwhile, graph neural networks unlock biological insights by capturing complex relationships in protein interaction prediction. These advances aren't just about making models smaller, they're about democratizing access to powerful AI capabilities, enabling sophisticated systems to run on smartphones and edge devices worldwide. Our third theme explores robustness and interpretability, the holy grail of AI research. Picture an AI system as a student who has memorized textbook examples but struggles with real-world problems. The work on out-of-distribution, generalization in transformers addresses this fundamental challenge by identifying 4 specific architectural mechanisms that enable AI systems to perform well on problems they've never encountered before. Additionally, CausalVerse provides the first high-fidelity benchmark combining realistic visual complexity with known ground-truth causal structures. This research addresses the reliability paradox. having incredibly skilled systems that can't explain their decisions, by making AI more transparent, interpretable, and trustworthy in unpredictable environments. The revolutionary discoveries, reshaping our understanding of artificial intelligence, span 6 major breakthroughs. First, control theory principles dramatically improve backpropagation through OCNOpt, an optimizer showing enhanced robustness while maintaining computational efficiency. Second, reversible model merging elegantly solves the catastrophic failure problem in low-rank model combination by constructing compact mathematical spaces from which original models can be recovered. Third, complex protein interactions can now be predicted using directed graph neural networks applied to sequence data alone, eliminating expensive three-dimensional structural requirements. Fourth, researchers identified 4 transformer architectural mechanisms that enable systematic generalization beyond training distributions. Fifth, context-selective state space models achieve near-perfect accuracy using 2 orders of magnitude fewer parameters than previous approaches. Today's featured paper takes us into the fascinating world where control theory meets neural networks. Optimal Control Theoretic Neural Optimizer by Guan Horn Liu and colleagues represents a rare research breakthrough bridging 2 seemingly distant fields to create something entirely new and powerful. The story begins with Liu's simple yet profound observation. There's a striking resemblance between backpropagation algorithms used to train neural networks and mathematical principles governing optimal control systems like those guiding spacecraft or managing complex industrial processes. Liu's cross-disciplinary curiosity, maintaining expertise in both machine learning and control theory, enabled him to see connections others might miss. His eureka moment came while working late in his lab, realizing neural networks could be viewed as discrete time dynamical systems. The technical innovation behind OCNOpt goes far beyond first-order optimization thinking. Traditional backpropagation stops at first-order approximations of the optimization landscape, like a hiker only looking at immediate terrain around their feet. The OCNOpt approach explores higher-order expansions of the Bellman equation, providing comprehensive views of optimization landscapes like a hiker, with detailed topographical maps and weather forecasts. The system implements layer-wise feedback policies that adapt optimization processes based on current network states. Imagine a personal trainer who adjusts workout routines not just from predetermined plans, but by constantly monitoring current fitness levels and adapting in real time. OCNOpt handles game-theoretic applications where different network parts compete or cooperate as agents, showing particular strength in training continuous-time models like neural ordinary differential equations. The implications of this control theory framework for AI systems extend far beyond having another optimization algorithm. If neural networks are truly dynamical systems, then the entire theoretical framework of control theory becomes applicable to understanding and designing AI systems. Concepts like stability, analysis, controllability, and robustness, refined over generations of control systems research, suddenly become relevant to neural network training. This connection brings decades of theoretical results into the machine learning toolkit, potentially leading to neural architectures that are inherently more stable, training procedures with mathematical convergence guarantees, and AI systems adapting behavior in principled ways as conditions change. The research opens possibilities for adaptive architectures that modify structure during training based on optimization dynamics, addressing challenges like the vanishing gradient problem systematically. Looking toward the future, today's research landscape points toward exciting new directions. Think of the current state of AI research as standing at the edge of a vast ocean, with these 18 papers serving as lighthouses, illuminating different paths across the water. The convergence of mathematical frameworks we've observed, control theory meeting neural networks, information theory informing causal learning, graph theory enhancing biological modeling, suggests movement toward a more unified understanding of intelligence itself. The emphasis on efficiency and compression techniques indicates a future where powerful AI capabilities become accessible to everyone, not just those with massive computational resources. Advances in causal reasoning and interpretability point toward AI systems that don't just recognize patterns, but truly understand underlying mechanisms driving observed phenomena. This could revolutionize scientific discovery, enabling AI systems to propose novel hypotheses about everything from climate change to disease mechanisms. Today's journey through cutting-edge machine learning research has revealed a field in remarkable transformation. We've explored how control theory can revolutionize neural network trading, how graph neural networks unlock biological secrets, and how rigorous evaluation advances our understanding of causal reasoning. These 18 papers represent more than academic exercises. They're blueprints for AI systems that will shape our future. The researchers behind these discoveries push the boundaries of what's possible, driven by curiosity, rigorous methodology, and visions of AI systems that are not just powerful, but also reliable, efficient, and beneficial to humanity. From elegant mathematics of optimal control theory to practical challenges of protein prediction, from theoretical foundations of causal learning to real-world applications in climate and healthcare, this research demonstrates the remarkable breadth and depth of current artificial intelligence research. This analysis was created through AI synthesis using Claude Sonnet-4-20250514 with text-to-speech synthesis powered by Deepgram and image generation through OpenAI systems. The synthesized content underwent human expert review to ensure accuracy and clarity. We acknowledge that potential oversights may exist in this analysis, and we encourage listeners to consult the original research papers for complete technical details and methodologies. All references to the original papers and their authors are provided to support further exploration of these groundbreaking discoveries. The synthesis process aimed to make complex research accessible while maintaining scientific rigor and acknowledging the innovative contributions of the original researchers. Subscribe to AI Frontiers to explore cutting-edge artificial intelligence research weekly. Share these discoveries with your network and engage in discussions about which findings surprised you most and what applications you envision in your field. The future of artificial intelligence is being written by researchers like those we've discussed today, but it will be shaped by how all of us choose to develop and deploy these powerful tools. Stay curious, stay engaged, and keep exploring the frontiers of artificial intelligence. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive preprint server.